Hello my dear students, this is Akash SD. Welcome to the ASD physics classes. Hope so you all are doing really great. So students, in this video we are going to solve the question from the chapter EMI, that means electromagnetic induction. Okay, let's go through the question. The question is, in the given circuit, you can see the circuit, the sliding contact is pulled outwards such that the electric current in the circuit changes at the rate of 8 ampere per second. At the instant, or we can tell at an instant, when R is 12 ohm, the value of the current in the circuit will be how much? In terms of ampere we have to tell. Okay, so first we have to note down the data here. Now, so first thing you can see very well here, what is happening that here, see, contact is pulled outward here. See, the contact is pulled outward. This one is telling very basic meaning. So you try to understand one thing, when this contact is pulled outward, so what will happen that here, the value of the resistance will increase now, because more resistance will enter into the circuit. Okay, so when the resistance will increase, what about the current? You know very well the current will decrease. Is it? Because from the Ohm's law also itself we can tell that now, when the opposition resistance is the opposition of the current. Is it? So when the resistance will increase, why? Because this contact is pulled outward, so that time current will decrease. Okay, so when the current is decreasing, that time we can write here, see, the current in the circuit changes at the rate of 8 ampere per second, and this current is decreasing. Decreasing current is always represented by minus sign. Okay, so I will write here minus 8 ampere per second. This is the main point to solve this question here. Okay, if in case they told that here contact is pulled inward, then what will happen in that situation? R will decrease, I will increase, and that time we will take this di by dt positive. I hope so concept is very clear. After that, very easy, not at all big deal. Then capital R value, how much is given here? You can see very well, it is given here the 12 ohm, and in the question they are asking at the instant what is the value of the current here. Okay, now after that what we'll do here, we will just use here the KVL. Okay, so see here, by KVL. Now, so you know very well here, see, this is minus battery terminal plus, and let's take the current will flow in this direction, correct? The current is flowing in this direction from the positive terminal to the negative terminal, is it? And if I put here the polarity, see here please, this is the plus minus, always like this, current will flow like this, this is plus, this is minus here, is it? So you know very well, in a KVL we have to always take the second sign. Now, so let's take here, I have started from here, so see from here the second sign is what here, 12. Okay, so 12 minus, remember that here, this we have to write here L into di by dt. As of now I am writing here 12 minus L di by dt. After that, let's take here, we are coming here second sign, minus, this minus IR, and again we are reaching to the same point, 0. So 12 minus L di by dt minus IR equal to 0. Okay, so we have to calculate here the I only. So see here please, I can write here IR is equal to 12 minus L di by dt. Okay, then after that what we can write here, as of now let's take here, this is I, R value is the 12. Okay, and here I can write here 12 minus, what is the value of the L? 3, and di by dt, it is what? A minus 8. Okay, so from here I can write here this 12I is equal to 12 plus, and we can write here the 24. Okay, then we can write here what is the value of the I. This I will become here 12 plus 24, it will become here the 36, by what we can tell here, this 12 will come downward here. Okay, so what we can write here, this value of I will come here 3 ampere. Value of I is coming what here? The value of I is coming here 3 ampere. Kindly see very well, is it? So here what we have to fill? We have to fill here the 3 ampere. And one thing I will suggest you, maybe you know this formula, na? When we are writing here the EMF across the inductor E equal to minus L di by dt, is it? You may think like this, okay, here this minus sign is there, so why I did not use in bracket then minus? Remember that here E equal to minus L di by dt we will only use whenever we are dealing with the graphs, whenever the graphs and all is there. Okay, that time only, very important. But whenever we are applying the KVL, that time this minus sign no need to include extra, because whether the current is increasing or the current is decreasing, based upon that all this sign will adjust, because I told you when the current will increase di by dt positive, and when the current will decrease di by dt negative. So this di by dt will take care of this sign. So when you are applying the KVL, no need to use this minus sign whenever you are applying the KVL in the circuit. Okay, remember all these things. So students, I hope so this very basic conceptual video is very clear to you. Keep studying, keep growing.